Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer, author, and software architect.
And I'm Beej, the journeyman developer sharing my journey in development.
Complete Developer Podcast is supported by listeners like you. We are now on Patreon at www.patreon.com/Complete Developer Podcast.
All your base are belong to us. Early 2000 memes aside, understanding the differences and similarities between ACID and base databases is important in architecting software solutions from small personal blogs to large enterprise level systems. In this episode, we discuss the ACID versus base databases. We'll talk about pros and cons of each and when you'll want to choose one over the other. But before we get started, Will, where do all your bases belong this week?
I think it's largely in React. So I've been doing a lot of React stuff, and it's been kind of interesting going through a course on React/Redux. And I tried that a few years ago and kind of struggled with some of it, with some of the concepts. And this time it was a breeze. I don't know if it was just a sharply better tutorial or if I just learned a bunch in that time. I don't know.
Sometimes familiarity with the topic, like going through it more than one time, helps you learn it better.
Yeah, it was really the Redux stuff that was strange to me. Like all the reducers and all that kind of stuff. It didn't make sense to me then. And this time I looked at it and I'm like, well, yeah, that makes total sense. I don't know what happened. Yeah, it's a real puzzle. But yeah, so that's what I've been doing. How about you?
We got our times in from the 5K I ran and did better than I thought. Like, seriously, a lot better than I thought. I ran it in 32 minutes and 35 seconds.
It's not bad.
Yeah, considering I'd been doing about 37, 38 minute 5Ks on my own. So did pretty good on that. I'm pretty happy with that. Of course, you know me, and I can't let well enough be alone. So I had to see if I could beat it. So I think like 2 days after I got the time, I went and did it in 31:05. And then today I did a 5K in 31 even.
There you go.
Yeah. Just pushing just a little bit each time, do a little bit better. So also working on my distance. Like yesterday I did 5 miles. So pushing the speed on my distance running a little bit. I did 5 miles in 54 minutes. Yeah. So not bad. But yeah, just enjoying. I guess I'm a runner now. So, I mean, I was talking to a guy at the gym because I'm an outgoing extrovert. So what do? I have conversations with guys at the gym and stuff. And so he was asking me about like what I was doing workout wise and stuff. And I told him I kind of mix it up, but I was like, lately I've been doing more cardio because I hurt my shoulder. I was like, I don't really consider myself a runner, but did a 5K the other day. And he's like, if you did a 5K, you're a runner, dude. So like, all right.
You might as well identify it.
Yeah.
And be something. There's no problem with that.
Yeah, I agree. So I'm officially identifying as a runner these days.
Saving money is hard, especially when you're always at Fleet Feet buying running gear.
True that, yo. It's expensive, man. Lucas Casadas is a fee-only certified financial planner. He owns and runs Level Up Financial Planning virtually out of Fort Collins, Colorado.
And just like us at Complete Developer Podcast, he focuses on helping you to not only establish a real plan, but to take action on that plan so that you can live and create your best life.
Guys, investing in financial planning services really comes down to whether or not you can improve your finances. With the help of Level Up, the compounding impact of making better financial decisions will easily pay for itself.
Level Up has a unique pricing model that will help you no matter where you are in your financial journey.
And best of all, Lucas is a fiduciary for his clients. And what that means is he's not here to sell you a product, but to help guide you to a better financial situation.
You can catch his podcast, Techie Personal Finance Bootcamp, where he covers financial topics that you probably face, and he interviews other IT professionals who share how they navigated their own careers. And you can learn even more at levelupfinancialplanning.com. Understanding acid and base databases is critical for any organization or individual who is involved in developing, managing, or using modern database systems. Both types of databases have distinct characteristics and trade offs, and choosing the wrong one can have serious consequences on the performance, reliability, and security of your application. Boy, have I lived that one a few times.
Yeah, I'm sure. ACID databases are designed for applications that require strict data consistency and accuracy, such as banking, e commerce, and just financial systems in general. These databases provide strong guarantees that all transactions are processed in a reliable and predictable manner, ensuring that the data is always in a valid state. However, these databases can be slower and less scalable in distributed systems. Also, they require more resources to maintain that consistency.
Yeah, and that consistency at scale, the cost of that does not scale linearly with the rest of your scale.
No.
And when you learn that the first time, what that actually means, it sticks with you forever. On the other hand, base databases are designed for applications that prioritize availability and partition tolerance, such as social media platforms, content distribution systems, and other distributed systems. These databases provide high availability even in the face of network partitioning or system failures, and can be more scalable and flexible than ACID databases. However, these databases may provide temporarily inconsistent data and can be more complex to manage.
So, in this episode, we're going to deep dive into ACID versus base databases. We'll start off looking at each one in depth, talk about the pros and cons, how you would use them, and then things like scalability, the transactions, recovery, and get into security. Finally, we'll wrap up talking about some hybrid solutions between the two. So let's go ahead and jump on in with Acid Burn. Sorry, I couldn't help the 90s hacker movie reference.
All right. So let's talk about what ACID stands for. It stands for atomicity, consistency, isolation, and durability. ACID databases ensure that all transactions are processed in a reliable and predictable manner.
Yeah. So atomicity, like atom, like an atom, small little thing. Basically, with this, transactions are treated as a single, indivisible unit of work. And if you remember your, what was it, sixth grade science, seventh grade, I don't remember what year it was. Obviously, I don't remember it that well, but the idea behind the term atom in like molecular structure is like it was the indivisible unit. It was the smallest you could get. Of course, now we found that there's even smaller things, but that was the idea at the time. So if any part of a transaction fails, the entire transaction is rolled back to its previous state.
Right. And the next point is consistency. So transactions must leave the database in a valid state, adhering to all defined rules and constraints. So basically what they're saying here is I can't say, well, I'm writing the data to this one row and yeah, this column's required and I'll fill it in later. It's like, no, later is now. You got to fill it in or not. And if not, it's going to fail and it's going to roll back.
Right. Isolation. That means that transactions must be isolated from each other, ensuring that they don't interfere with one another. So you can't be adding a row and updating that same row at the same time.
Right. Also bear in mind here that interference does not mean performance interference. It means data interference. Because you absolutely can write a transaction that will interfere with every other transaction on that database. I've done it. So have you.
Yeah. Well, we won't go there.
Yeah. And the final one is durability. Once a transaction has been committed, it's permanent and it will survive any subsequent system failures. Again, assuming that the data is moved off system if the system is actually destroyed. Right. Those kind of things. In other words, it's permanent, not in a position to get rolled back by the OS or something like that because of some weird.
It's permanent to the lifespan of the system.
Right. It's permanent like your permanent record in school.
Yeah. some weird things on mine.
Yeah.
I actually like to get my hands on it and see. But anyway, now let's talk about base database. I don't know why I emphasized the base in that word, but whatever. Does it like annoy you when people call them databases?
Nope.
Okay. I hear it both ways and I'm like, which is right? Because there should be one definitive truth.
We're from the South, so we've got enough odd pronunciations that I don't feel like jumping somebody else's case in any direction on something like that, because I know that will come back at me.
Oh, yeah. Yeah. And I could very well be the one pronouncing it wrong, but
I think it kind of depends on what part of the world you're from, whether you say data or data.
And I think I just say data because I watched a lot of Star Trek as a kid.
Yeah. Well, and I think that's kind of the Southern thing too. So
probably. So getting back to the base of the conversation.
Oh.
Base stands for basically available, soft state, eventually consistent.
I feel like that's somebody's dating profile. You might want to explain what that means a little bit more.
Oof. Yeah, having been on the dating sites as recently as earlier today. Yeesh. Base databases prioritize availability over consistency and are designed for distributed systems. So the idea is it's always available. It may not always be consistent.
Right. So basically available. Base systems are designed to always provide some level of availability, even in the face of network partitioning or system failures. Whereas your ACID databases, when those kind of problems are coming up, a lot of times it's just, hey, it's just down because it can't ensure consistency. That consistency guarantee costs a lot.
Soft state means that data consistency is allowed to be temporarily inconsistent. What this means is that a base database may provide stale data until all nodes have been updated.
Right, which is actually it's a safety thing, honestly. That means that if you've got two separate nodes, they aren't getting different values for the same record. If you're distributing other things, that can get really, really weird where like accounting gets messed up because it keeps the inconsistency from propagating at the cost of potentially being behind. It's almost like a dirty read on a ACID compliant database in some respects, because you'll get that sort of effect sometimes too. Eventually consistent means that over time, all the nodes in the system will eventually reach a consistent state, provided that there is an open communication channel again at some point in the future.
So now we're going to get into some pros and cons of each database or each architecture, how you would word that. Anyway, so we'll start off with the ACID pros and cons, and then we'll get into the base pros and cons. So the ACID pros include reliability and predictable transactions. You know what is going to happen when you send something to that database.
Right. And it's in a consistent manner. So like you can determine what the order is going to be. So, order of operations, matters a great deal.
And the other nice thing about it is it forces that consistency and accuracy in your data. Like you don't have to worry about accidentally not filling in a required field because it's going to throw it back at you and say, I forget what the error is in the various databases, but it's going to throw an error and it's annoying and frustrating and gives you a headache.
Right.
But yeah.
Now the downsides of ACID, it can be slower and less scalable in distributed systems. Although I will say this, until your system actually has to be distributed, that I have not found that is not as much of a problem. If you're over engineering ahead of time and doing the base database and you've only got 10 users, the ACID one will probably be faster at that scale. It's just later on is when it hits the wall. It also requires more resources to maintain consistency. I mean, if you put constraints on a system, it takes more resources. It's just the way life is.
Somehow I ended up getting all the positives and you get all the negatives. It fits our personality, right? I just realized I'm about to do base pros and I'm like, that's base pros, not bass pro.
And not bass pros as in, like deep voiced song or something.
Spoken word with a bass line.
Yeah.
Drop that base. All right. Anyway, please don't drop the base. It could damage it. Wow, that was really bad. Oof. Yeah, no. All right. So, pros for the base databases. They are highly available in distributed systems.
Because they're distributed.
Yeah. Like they're distributed. That's what the BA stands for, is basically available. Like the whole idea is availability. Whereas the ACID, the idea is consistency and accuracy. The base, the idea is that availability. They're also more scalable and more flexible.
Yeah. Because the consistency requirement, again, on the ACID side, makes a lot of things not possible because you're trying to make things you don't want impossible. A lot of times that means that you're giving up things that you do want to be possible. That's the game of life right there. So let's talk about some of the cons. In a base database system, data may be temporarily inconsistent. Now, the length of time of that inconsistency varies depending on a lot of things, but it is possible to have two separate calls and potentially get different data or to get data that's stale in some method. It can also be more complex to manage. Part of this is just because, hey, it's a structure that's built to be distributed. Those are not going to be simple, just life.
So, kind of briefly, we'll go over a few use cases for each of the databases. ACID databases, and we kind of hit on this a little bit. They're really well for banking, e-commerce, and financial systems that require that reliability and accurate transactions.
And the consistency of order in said transactions. I mean, especially you think in banking, like when did my account get overdrafted? Bank of America got nailed on that because they were actually reshuffling that order so that they could burn people on overdrafts.
I got hurt by that a few times when was in college?
I feel like it was in college or
it was either in college or like a year or so after. Basically, when living paycheck to paycheck, and it was you get the paycheck on Friday and put it in the bank, pay rent on Saturday, and they would take the rent out before the paycheck.
Right. Or they would take the biggest transactions first, so it ate up the whole paycheck. So if you had multiple things that were small, you got dinged repeatedly on the overdraft charges. That is not considered best practice in a financial thing, right? There's a lot of shenanigans you could pull with moving transactions around. So in these kind of systems, this is kind of part of the controls. Base database use cases are more like things like social media platforms, content distribution systems, other distributed systems that prioritize availability over consistency. I will tell you a lot of those kind of systems, what I have seen, not necessarily with social media, but with some of the others, is that they tend to have a ACID database for the content management inside the guts, and they have a base database outside. So stuff gets pushed out there to be interacted with because they want they want that control over the inner core of their workflow. But when it's the stuff that's for the public, it's not as critical.
That actually makes sense. And we'll talk about that some when we get down to the hybrid solutions.
Yeah. I mean, we should just call those saltwater.
Yeah. I call them volcanoes.
Well, acid plus base, right?
Yeah. Well, I mean, that works too. I was thinking what happens when you mix an acid and a base, you make a volcano. Anyway. So now let's talk about scalability. We've said this a couple of times already, but ACID databases are known to be less scalable compared to base databases.
Yeah, and that's because they prioritize data consistency, which is going to lead to performance issues when you handle a large number of simultaneous transactions. Because you got to say, hey, only this transaction is working with this thing at this time. So the best way to think about this from a developer perspective, and this was the way it was explained to me a long, long time ago, back in the day, when you had a source control system like Visual Source Safe, you actually checked a file out. So it's like, hey, I need to edit this module file. I'm going to check it out. I'm the only one that could touch this file until I check it back in, right? That ensured atomicity and consistency in regards to the code base. As teams scaled, that obviously did not work. And as people went on vacation and other crap happened, and so you got distributed systems like Git that instead of doing things that way, you could actually kind of play with the order. You could do other things. You could do merges. It's sort of that same scaling factor that influenced source control systems. It's just, it happened to databases too.
Yeah.
If that makes sense.
Mm-hmm. That makes perfect sense. No. Now, on the other hand, base databases prioritize availability and partition tolerance. And what this does, it makes them more scalable in the distributed environments they're designed to work within.
Right. And again, like going back to the example with Git is kind of a pain if you're the only one working on something. Like you will get bitten by a merge conflict that is stupid and it will waste an unbelievable amount of your time. If you're a solo dev just doing something, it just happens, right? Like it's overhead and you're paying the price for this thing that you're maybe not getting what you want out of it. It's just that if you were doing the other thing, you'd get bitten by that too. It's just, it'd be a different set of problems.
A different shape of teeth.
Yeah, it's a different shape of teeth.
I mean, do you want to get bitten by a wolf or a shark? I mean, that's kind of what you're talking about here.
Right.
A baby shark?
I don't know.
Sorry.
Oh, man. There you go. So, stabilizer for scalability is understanding your application's specific requirements and choosing the database that best suits those requirements. And I'll add to that, your requirements are going to change.
Yeah.
So, whatever you think it's going to work great right now may work great until it doesn't. Be aware that you may have to change this at some point or start determining which roles in the app have to move to which place and have both.
Yeah. No. So now we'll talk about data models in each of the databases. ACID databases use a relational data model, while base databases use a NoSQL data model.
Yeah, and I don't know if that's actually, is that true across the board or is that just in general?
It's more of a generalization.
It would make sense because the base databases tended to happen with more scale and newer tech, whereas your ACID compliant databases, these are the old systems that were like, hey, every byte is sacred.
I think originally it was like, all right, ACID is relational and base is NoSQL. Like, but times they are changing. I don't know. Is that Dylan? Yeah.
Yeah.
So you may be able to get an ACID compliant database with a NoSQL data structure and create a base database with a relational data model.
Yeah. I just would think that the use cases on those might be a bit narrower.
Oh, yeah. I'm sure they are.
By the time you're going distributed and stuff, it's like, hey, this is on the internet. I need a big blob of JSON and a deep load of a thing. You know, I want an entire aggregate route, not a row. And when you're doing ACID databases, you probably are trying to just touch a row and not touch things that are not that row. It makes sense. I'm not sure if that's across the board or not. I was kind of curious if you'd seen anything.
Trying to think if I've actually seen.
I feel like AWS probably has one with a code name that is completely impenetrable. You know, like AWS dorsal fin or something. You know, it's just something. It's like, why is that related to a database?
And I don't know. I haven't personally seen anything like that. Now, I've seen people use NoSQL as if it were a relational database because that's all they know.
Yeah. And sometimes it's okay. You get away with it for a little while.
When I say people, I'm looking in the mirror here. So,
yeah,
because I've done it just because I was more familiar with the relational as I got more, but it went more NoSQL as I got used to that.
Yeah. Well, and I think the other thing is the thought process there is when you're like, hey, I'm pulling back an entire aggregate route and all the crap that's under it versus I'm limiting the number of fields I'm pulling back because it's just these two tables and I'm joining and it's just a different headspace and it takes a minute. Yeah. So I wouldn't feel too bad about that. But relational databases are good for structured data while NoSQL databases are better for handling unstructured or semi-structured data. So for instance, a content management system, probably better as a unstructured data. I have worked on systems that were built in a structured data fashion, and they were very, very limited because of just what you could do with the tables and it still be performant.
Yeah, I kind of like semi-structured just because I like having that structure because I'm unstructured enough as it is.
Yeah,
that didn't hit as well as I thought it would. So the stabilizer for data models is to understand your data and choose the database that fits your needs. Again, going back to what Will said before, your needs will change. It's not a matter of if, it's a matter of when and how you're able to mitigate that, which that's a whole different podcast episode that we should do.
Yeah, it's understanding that if you survive long enough, that a different survival strategy becomes necessary. And if you don't survive long enough, it was actually necessary before. So it's pretty much a universal constant. It's also important to consider the potential future growth of your data and how well the chosen database can handle it. I will say that as far as just like raw size, your relational databases can handle a lot more than you might think. I've seen some crazy stuff with Postgres. That said, once you get it big enough, it gets to the point where you're going to have a hard time moving it.
Mm-hmm.
And you just have like a physicality to it that is very, very real. Like trying to add indexes to a table that has 250 million rows in it. I've tried it. You know, like you kick that thing off on Friday and you come back Monday and the database server is still tied up and you have to basically terminate that operation. It's bad. So you probably don't want it to get that big on that kind of system.
So now we'll go into discussing transactions and how each of the databases handle them. ACID databases have support for complex transactions where multiple actions are combined into a single atomic operation.
Right. And this can include nesting of transactions too.
Yes.
Which is mind-boggling to me how that would work at a low level. Like, because a transaction is completed and it's committed, but then it's wrapped in another transaction that is incomplete and rolled back. Obviously, the outer one is supposed to win. I know you have to go back, you know, like it basically goes back through the transaction logs and does stuff. I'm like, how do you keep all that stuff straight? Just from the coding side, I don't like them. I would hate to think about how you'd have to implement that at an arbitrary depth in a database of arbitrary size. That sounds horrifying to me. And if anybody out there has done it, let's have a conversation on here. I'd be very interested in hearing someone's tale of doing it, not in doing it.
Yes. I want to hear about Frodo taking the ring to Mount Doom. I don't want to go to Mordor myself.
I want to hear your tales at Iwo Jima. I don't want to storm the beach. Sorry, not my jam. In contrast, base databases typically don't support complex transactions, but instead rely on simpler operations that can be executed independently.
Yeah. So basically, an ACID database has one or two very big, complex operations. It goes back to a conversation we had, I don't know if it was last week or I think it was last week, about
put and patch.
Yeah.
It's what it makes me think of a little bit.
I was thinking more like between those big bloated calls.
Chunky versus chatty.
Chunky versus chatty. Yeah, that's the word I was looking for. Yeah. That's kind of the difference here. Whereas ACID is more chunky and base is more chatty.
Yeah. Although, I think you could probably present the calls to the surface of the database in a chunky form and it'd be operationally chatty under the hood. It's also going to be chatty when you send a big wad of data to a relational database and push it in as a chunk just because of the network infrastructure. I get what you're saying, but it's definitely an interesting headache to think through all that.
It is for sure, man. For applications that require those complex transactions, your ACID database is going to be a better choice. However, applications that prioritize availability over consistency, again, going back to what the purpose of your application is, then your base database may be better option for that.
Yeah, I kind of wonder if, the end result is eventually going to be that everything is a base database with some kind of document type structure.
It does seem that things are going that direction.
Because that's the paradigm that we used before we had databases. And then we relationalized all the databases and did the whole ACID compliance thing. And now we're back to, hey, I need to manipulate business logic in a structure. And then I'm going to cram it into a relational structure because reasons. Like, I feel like that is going to drive the system to eventually all be base type things. And you're kind of seeing that in a lot of the relational databases. They are starting to support JSON operations and some of those kind of things. So
Goes back to the start of the episode. All your base are belong to us.
right.
Sorry, man, I couldn't help it.
So let's also talk about recovery, not from conversations about acids and bases, but actually from database recovery. Acid databases have strong durability guarantees, which ensures that committed transactions will not be lost due to system failures. Either the transaction went in or it didn't as a unit.
On the other side, base databases may rely on weaker durability guarantees, such as replication or eventual consistency, which can result in data loss in the event of a system failure.
Right. And when choosing a database, it's important to consider the criticality of the data being stored and the level of durability for which you want to pay. There's required, and then there's also, hey, what can we get away with?
Right.
Because a lot of people really are not at peace with the thought of losing data. And in some apps, hey, like you don't want to lose financial transactions. Like that's a big no-no. But a social media picture getting posted, and oh, by the way, it's probably been fanned out to 3 or 4 other databases, and it's eventually going to make its way back if this particular system goes down. That's not that big of a deal. It's the same thing with the eventual consistency. Like eventual, most of the time is in milliseconds, seconds, maybe a minute. It's not like, 3 days from now, we're going to fill this thing in, right? Because it has the same problems that a long-lived Git branch has, right? Like you don't want that, and they don't want that in their database system. So they're going to optimize for not having it to the degree that it's possible.
Mm-hmm. So now let's talk about security, everyone's favorite topic. ACID databases typically have strong security features, such as access controls, encryption, and auditing.
Right. And they have those because the reason you have those transactional guarantees and those durability guarantees is because the data is expensive data. It's very sensitive. You have regulatory stuff around it, and that other stuff goes with that. It's just kind of baked into that cake. Your base databases may not have the same level of built-in security features, but they may provide more flexibility for implementing custom security measures. So, like a lot of times they will have a web API type setup. I mean, like if you're, talking to like Firebase or Mongo or some of those, they've got structure that you wouldn't see in the other types of databases. And they're going, okay, well, if you're going to implement more security, you're probably going to be putting something in front of this database. It's not the database necessarily.
Mm-hmm.
That's the issue here.
No. Now, it's important to consider the security requirements of your application and choose a database that provides the necessary features and flexibility to meet those requirements. So, do you need it to have that access control, that encryption, that same kind of stuff like that the ACID database is going to have? Or do you need it to be more flexible, allowing you to have more control over your own security?
Right. And does it do encryption at rest? Are you willing to pay for that for the type of data you're storing? Is another great example of the security stuff. And bear in mind, a lot of that stuff isn't necessarily what you want. It's what the regulators want. And you should probably go along with them, by the way. I'm not saying that they're wrong. It's just, it's not all about you. And they may have some ideas about, what needs to be encrypted and protected. And I think that that's another thing probably keeping the ACID databases alive is that we have learned that we have to be concerned about our data. And the European Union, I think, is doing better on this than the US is, considerably, considering that people actually get in trouble for leaking things. But it's going to get everywhere. And that's probably one of the main things holding ACID databases up there, because it is so much easier to deal with base database systems because you're not fighting those transactional constraints at the same level. It works more with the way your code works and the data structures there. You're not like shifting the structure of data so you can work with it back and forth. You don't have that impedance mismatch or impedance mismatch, however you want to say it, database. So the final point here, hybrid solutions. You're probably going to end up with one of these over time. Some databases are designed to provide a hybrid approach that combines the benefits of both ACID and base databases. Bear in mind too, if your database system of choice doesn't provide both, then you just find a database that provides the other side of it and figure out how to make the integration work.
Now, these hybrid solutions may provide stronger consistency guarantees than a base database alone, while prioritizing availability and scalability more so than an ACID database.
Right. And, I want to say that like RavenDB and some of those were really working on that. I don't know how far they got because I haven't been following them in a while. I haven't been in an environment that used them, but yeah, I would say that, hybrid solutions may be a good choice for applications that need to have the strong consistency guarantees, but they have to be able to scale, right? Like the structure of your data is not necessarily the way that your app is organized. You almost have to decouple those two concepts in your head at some level, or you're going to get stuck in one and it's going to hurt.
So guys, understanding the difference between ACID and base databases can help you make informed decisions about which database to use for your application. By considering the specific requirements of your application, such as performance, scalability, consistency, and durability, you can choose the database that best fits your needs and ensures that your data is accurate, reliable, and secure. That's pretty much all we got. We will catch you guys next week.
If you have a question or comment, please email us at neckbeards@CompleteDeveloperPodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
For references, show notes, and extra tips and insights, be sure to check out the website at CompleteDeveloperPodcast.com. Help us make the show possible by supporting us on Patreon at patreon.com/CompleteDeveloperPodcast. You'll get extras, including a weekly aftercast where we discuss the topic of the week and bonus material with some of our patrons.
You can also follow us on Twitter at CompleteDevPod, like our page on Facebook, and follow us on Instagram to keep up with news about the show. Join the conversation anytime via Slack by signing up at slack.CompleteDeveloperNetwork.com. Thanks for listening. See you next time.